Hello class, welcome to our first lecture, Introduction to Whole Numbers. Here our focus will be on these objectives. We'll be looking at place value and rounding whole numbers, and these are the objectives we'll be touching upon. So as we prepare for algebra, we need to first look at how the numbers work and how it sits on the number line. And so we'd like to always use the number line as a reference. Now, the most common number line you would have seen is the ruler, right? You can use the ruler to kind of see how it is. But the ruler only gives you a certain set of numbers, particularly only the positive numbers. So let's start with how real numbers work. Okay. So first we have something called natural numbers. As the name says, it's natural, meaning if you put out your fingers and you start counting, right? So that's why we call them also the counting numbers. You will start your first count with 1, right? You can't count a half with your finger. You can't count a 0 with your finger. So you count from 1. So 1, 2, 3, etc. And it goes on. Now we like to write them as a collection. A collection in math means a set. So we always include them inside curly brackets to indicate that it is a set of natural numbers. And then the discovery of 0 made a huge difference to the history of mathematics. And I'm very proud to say that it was discovered by an Indian mathematician named Aryabhatta, way before all this modern mathematics, right? In fact, modern mathematics became modern only because of the discovery of 0. So this 0 really opened the doors to what we call as whole numbers. You really can't miss this because, in the word whole, you have the O, which reminds you of 0, right? So 0, 1, 2, 3. So 0 got added to the natural numbers and 0 became the origin, okay? So 0 is the origin. So 1 wasn't the origin, there was 0 that was the origin, which makes a lot of sense now, because if 1 was the origin, how would you measure something that's fractional, right? If you want to just take half of it. So half of it would definitely be a value less than 1. And so if there is a value that's less than 1, then what was the starting point? So that is how 0 came to be the origin. Okay. Now we will talk about the other numbers, but for the focus of this lecture today, we will look at only the whole numbers. Okay. So if I gave you a list of numbers, okay, for instance, if the list was like this: 0, 1 over 4, 3, 5.2, 15, 1 over 5. Among these, what would you call as counting numbers and what would be whole numbers? Okay. And let's write them as a set, as a collection. Now remember again, if you look back at the definition, counting numbers are things that you can count naturally. Right? You can't count a 0 naturally, you can't count a fraction naturally. You can count 1, 2, 3, these numbers naturally. So what will those be? So I will say natural or counting numbers. That set would be 3, 15, and 105, right? And what would be the whole numbers? Remember how whole numbers will have the 0 included in the natural set. So here we do have a 0, so that becomes part of the collection. So we have 0, and of course all that we had collected under the natural numbers. Notice how we ignored the 1 over 4 and the 5.2, because this is a fraction and this is a decimal. We'll be looking at these things in detail. But because this is a fraction, that's a decimal, they do not come under these categories, natural or whole, right? So we got that. Next, we want to look at the place value of a digit. Place value is definitely helps us is definitely a concept that helps us to understand what is a number worth, right? So when you look at just numbers, maybe you don't consider it as much, but we say in terms of money, think of it, the value, the place value really matters, right? So if it is 223, or if it is 230, it makes a difference, right? Because the place value would tell us or help us determine which value is stronger or larger than the other. So for those reasons, we have something called the place value chart. So we want to look at the place value chart. Remember, these information that I'm cross-referencing in my lecture are coming from the ebook. The ebook is your free open source OpenStax book. Those details are there in Canvas. So, and the link to the book is also given to you there. So you will go into that and locate our section, and this is our first chapter, so it's right in the beginning, and you can go through those notes. So I follow my lectures very closely with the book, so that you have a way to go back and reference and look at more explanation on these things. It has a number of solved examples and also some exercise problems. So all your homework problems are drawn from here. So you and this book is free, so you can access it anytime from by downloading it or from the internet. You can also, if you'd like to, you can request a printed version, a PDF version for a small fee. That can also be arranged, but it's a huge book, so you really don't want to print all those pages. And some of the advantages of keeping it as an ebook, as an electronic version, is that you can zoom out, zoom in, and you can also use the search feature to search. Like for instance, if you don't know where you first saw the place value chart, you can just go to the search box at the top of the book, the ebook, and then you can just type in there place value and it's going to pull it up. So for all these reasons, having it in the electronic version is a smarter choice. Okay, so now we have the place value chart, and it has you always read the chart from, you look at the chart from the rightmost end and work towards increasing order to the left in this case, right? So you have the ones, thousands, millions, billions, and trillions. And you can see how they are each groups of 3, right? So the ones group has 3 places, thousands group has 3 places on top of the 3 from the ones. Millions has 3 places on top of the other 2 categories. So millions actually will be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's where. Once you get to the 10th position, it moves on to the billions. They have 3 there. So they're all grouped in 3s. But if you want to see the further split here, you can see that it's ones, tens, and hundreds. That forms the ones portion. Then you have thousands, 10,000s, and 100,000s. That forms the thousands. Then millions, 10 millions, 100 millions. And you don't call 1,000 millions, right? If it's 1,000 millions, it actually becomes a billion. So you only go up to the 100 count of it. Okay. So that is the same style that you follow from the ones category. So whatever we have in the ones category is what is reflected in each of the other categories. Okay. So if I have a number, I always write it from the reverse order. Okay. So let's see. I'll give you a number here. The number is 5, 2, 7, 8, 1, 9, 4. Notice how there are no commas. It's very hard to read. I don't even know how to read. I just listed the numbers. Right? The first thing you want to do is remember how they were grouped. Right? They were grouped in 3s, right? And you always start from the rightmost end and work in this direction. Okay? So 1, 2, 3, put a comma there. 1, 2, 3, put a comma. So you got 2 groups of 3 and 1 group of 1. Right? So you want to actually now look at it in the place value chart. So in your place value chart, you start by entering the 4 under the 1s, 9 under the 10s, 1 under the 100s, and so on. Okay, if you did that, it's going to look like this. So the 4 is under the ones, 9 under the tens, 1 under the hundreds, 8 thousands, 7 with the 10,000, and so on, right? Now if you look at it, you will be able to actually read it. Now this 5, what is the place value of 5? Millions, right? Millions is the place value. The place value for 2 is 100,000s. The place value for 7, 10,000s, and so on. So if you were to look at each digit is each number in this entire number, right? Each position. So each digit has its place value indicated in this chart. But if you were to read this, as a number, based on the place value chart, how would you do that? So you're going to do that as 5,200,000, 7 10,000, 8,000, 100, 9 is tens, and 4 is ones. So if the question says, what is the place value of digit 7? Then you will simply say the place value of the digit 7 is 10,000s. Okay? But how would you read this as a number together? That is a little different, right? So you can read it as 527,008,194. That's it. So you're not going to read it as separately. The first time I read it separately because I was trying to match it with a place value. But when you read it as a full number, you're going to say 5 million. I got it mixed up. I apologize. You're going to read it as 5,278,194. Okay. You know why I suffer there? Because of the lack of commas. But here, when I have the commas, I can read it better. So, this is the millions group. This is the thousands group. And this is the ones group. Remember the groups? That way it is easy for me to read this. So I'll say 5,278,194. Okay. I struggled a little bit without the commas myself. Okay. I missed out on that. So anyway, so this is a lot easier when you have actually the commas. So let's do another one, just for me to redeem myself. All right. I have 63407,218. Okay. Let's do the commas and let's get their positions. So you can always now you might be really missing the place value chart. If you feel that way, feel free to go back to the video in time to look at that and pause at that chart. Or you can parallelly, this is the best way to learn. You open your ebook parallelly and go to the place value chart there and then use the reference to go back and look at the chart. Okay. If it was in class, we would be either looking at the book ourselves or, there would be a place value chart or something that's hanging on the wall. So think of it like that. You have the reference now to go back to the ebook to cross-reference it. All right, let's do the grouping. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, no. So then here I have the groups. This is the ones group. This is the thousands group. And this is the millions group. Now you can definitely look at the chart to see which position of millions this is. So if you look at these, so this was where it was, right? 6 and the 3. 6 and the 3 were here. I'm not able to write there, but you know that 6 was in the 10 millions and 3 was in the millions. So you have the 6 and the 10. So you will read it as 63, right? So coming back here, I will read this as 63,407,218. Does that make sense? Because the 6 was in the 10 million position. This was in the 10 million position. That will be how you will read it together. 6 and the 3 will be 63. 63,407,218. Okay. We'll do just one more and then move on. So I have 5, 1, 9, 7, 1, 1, 6, 4, 1, 3, 2, It's a good idea for you to pause the video and do the problem on your own, and then play the video to view my explanation. Okay, that's what you would do in class too, isn't it? When I give you this problem, I wait for the class to work on this problem, and then we will discuss and share the answers, and then I will provide the explanation. That's the same style. You just have to have that personal discipline to pause the video here and work it on your own whenever you see multiple examples and you got the idea. You can always try it on your own. Okay, let's do the grouping this time. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, and there's 1, 2, 3. So this will be the ones. This will be the thousands group. This would be the millions group. And this would be the billions group. And to read, to help you read this, you know, this is 100 billion position, right? That's the place value for the 5. So then I will say 519 billion, 711 million, 641,328. It's a mouthful, but it's also a huge number. So this is how you would read it once you have separated them by their groups. Okay, I keep calling them the groups, but the technical name for that is period. Okay, each period has 3 positions in them, right? So we'll just use the word groups. It's a lot easier. Now you will be asked to name a number. Name a number. Name a number is what I just said to you as to how you read the number, but you're going to write it in words for that. Okay. So when you name a number, you are going to separate it out like this, and then you will read it. So for instance, if this was the world population or something like that, so you will say, so how do you say how many people there were, right? That is the whole idea of naming. If it was a dollar value, how would you read this value? So then I'm going to write it in words when they say name it or read it. You know, reading is like more verbal, so they use the language name it so that you can write it out. Okay, so I will say 519 billion 7. So you can just put the dash there so that you know 111 million. It was a mouthful, so you can imagine it's going to be really long to even write it out. It always helps to keep that comma to maintain that too. So you can put the comma there. 641,000. We don't say and. In some places they say the word and, but at least in the US the word and is reserved for decimal places. So they don't use the word and. It just seems a little abrupt, but you just go ahead and say 328. Notice how there's no and anywhere. Okay. So that is how you will name it. Name the number. That is how you do it. When it comes to estimating, you know, to get a rough idea, we like to round whole numbers. Okay. Now, if you looked at the previous example, the numbers were so specific, right? It takes a while to you know, fully even explain that number exactly. But if you want to give somebody a rough idea, okay, so for instance, you're saying, say this was a dollar value. If you don't want to give the exact value, you want to say the neighborhood of it, then you can just say, oh, it was about more than $500 billion. It was more than $500 billion because it was 519 billion, right? So you can say that, but how did I come up with that? So you just rounded it, right, in some way. So there is actually a rule by which we round. And so we like to round whole numbers. If you look at the number line, remember the number line is always helpful to us. So so you say in your number line you had say this is a zoomed version. You're looking at numbers between 70 and 80. 1, 2. I know it's not equally spaced. I was afraid I would run out of space. All right. So you do have, that, let's make that as the middle mark. Okay. And this is the left end and this is the right end. Now, whenever we round a whole number, we like to round it to the nearest 10. Okay. So rounding a whole number is the same as rounding to the nearest 10. When we say the nearest 10, then you notice that this and this are the tens, right, in the extremes. So it's either the 10 with a 0 there, 10 here with a 0 there. So if I were given, say, the number 72, then I look for the number that's closest, the closest 10 for 72. The closest 10 is 70, right? So 72 rounds to 70. You can take 74. 74 also, the closest number, 80 is far off, 70 is closer. So 74 also rounds to 70. Okay. If I choose 77, notice how 77 is closest to 80. So 77 rounds to 80. And 79, of course, is very close to 80. So 79 rounds to 80. Of course, the difficult part is 75. 75 is smack in the middle. So how do we say which one it's closer? Is it closer to 70 or is it closer to 80? So for these kind of situations, mathematicians have come up with a rule, so we all agree the same way. So they're saying if it is right in the middle, we will move it up to the nearest higher number. So we always round it to the higher number. Because you can't say the nearest number, because that is the problem right here, right? You don't know whether 70 or 80. Both of them are equally apart from 75. So there is no nearest. Therefore, the rule says go for the higher number. Okay. So 75 rounds to 80. So this kind of helps us to come up with a general procedure. A general procedure is that if you have 5 or above, round higher. And below 5, round to the lower number, to the lower 10. This is the general rule for any number, So how does this rule work? So here we go. Now if they say 7, so because we are looking at the tens, the nearest tens, let me take the same example. Okay. Let's say 77. Okay. Because we are rounding to the nearest 10, this is the position that needs to become a 0. Yeah, because that will be the nearest 10 rounding the estimation. So for that, what we do is we take the 77 and look at the, so when I say I'm rounding it to the nearest 10, this 77 should either become a 70 or an 80, right? Because that's the nearest. In either ways, this becomes a 0, right? This should become a 0. So what we're saying is, look at the number to the right of the number you wish to round. Yeah. So this approximation it depends on the number that you're looking in the tens place, because you're trying to round this to the nearest 10. This is the ones place. Okay, so when we say nearest 10, look at the number in the tens place and look at the number to the right of the tens place and use the rule that I have provided here. If this number is 5 or above, right, if this number is 5 or above, then what you will do is you will come back, okay, and you will add a 1 to this number and you will turn this into a 0. So 7 plus 1 is 8 and a 0, so it becomes 80. Okay, that's how you will round higher. Round higher means add 1. Do not change. Okay. So then let's look at 73. So once again I want to round to the nearest 10. So this is the tens place. And this is the ones place that must become a 0. So I look at the tens place and I look at the number to the right of it. If you go back to the rule says if it is below 5, you round it lower. Okay. So according to the rule, if I'm looking at this number, I know that the rule says round to the lowest number, which means no change. So you keep the 7 as it is, but you know this always has to become a 0. So that's a 0. So this becomes 70 automatically, lowering it or rounding it to the lower number. Okay. So let's do a different number. Okay. So let's say okay, just to keep it fun, 1, 2, 3, 4, 5. Okay. So if I say round it to the nearest 100, then the first thing you want to do is, you know how grouping really helped us, right? That will give you an idea of how to read this number. So it's 12,345. So it helps you to even read the number, and that is always helpful. Then we come back and we get their positions. This is ones, this is tens, this is thousands, this is, I'm sorry, this is hundreds, I said thousands. This is hundreds, and this is thousands, and this is 10,000, right? These are the positions. 100. So they said round to the nearest 100. So this is our hero here, right? So if that is what is zeroed in, okay, it's gotten a little busy, so I'm going to write it out here. Now because this is the important number, that is where you want to round. If you round it, you know these two must become zeros. That's the idea, right? The number to the right of it must become 0. But even before you turn them into zeros, I want you to look at the number to the right of it. So this is the 4 is the number that's immediately to the right. Don't worry about the 5. Look at the 4. So the 4 is the number you're looking, and go back to the rule. If it is below 5, no changes to it. So I have 1, 2, 3, and there is 4 and the 5. So there is no change. Okay, so there is no change. So you write it as it is, 1, 2, 3, but these will become 0. So 0, 0. So this becomes 1, 2, 3, 0, 0. That is how you round it to the nearest 100. And see how it ends with 100, the 2 zeros. So how do you read this? So this will be 1, 2, or 12,345 rounds to 12,300. Yeah. We'll keep the same example, and I'll say let's round it to the, so let me write that out here. 1, 2, 3, 4, 5. Round to nearest 10. So you know that 4, we identified 4 to be the tens position, right? So 1, 2, 3, 4, 5, and I put a line there because you're interested in the number to the right of the tens position. Okay, so the 4 did not make any difference, meaning, sorry, the 5 is a number that is, let's go back to the rule. The number says, the rule says, if you had 5 or more, 5 or above, add a 1. If it is below 5, do not change. So this is a 5, exactly a 5. So I do have to add a 1. So then that will be a plus 1 here, and this becomes a 0. So what does this become? 1, 2, 3, 4 plus 1 is 5, 0. So my number 1, 2, 3, 4, 5 rounds to 1, 2, 3, 5, 0. That's the nearest 10. That is rounding to the nearest 10. Okay, let's do rounding to the nearest. Let's use a different number now. Okay. So different number would be 5, 4, 3, 2, 1. Okay. Oh, it still doesn't do the trick for me. So you know what? 5, 6, 7, 8, 9. Okay, because I'm looking for larger numbers to show you the round to the nearest 10,000. Okay, so that's your ones, this is your tens, this is your hundreds, this is your thousands, and this is your 10,000. So round to the nearest 10,000 means I'm looking at this 5. Right? That's the position, and but that's right. But you're looking at the number to the right of it. Okay. This number is above 5. That means you have to add a 1 to this and turn all of these into zeros. So what do we get? We get 6, 0, 0, 0, 0. So 56,789 rounds to 60,000. So that is how you do the estimation. Okay. Now if there is no change, again I'll give you a quick change of numbers. 5, 3, 7, 8, 9, and if we are asked to round to the nearest 10,000, you will do the same thing, but because the 3 is below 5, right, there will be no change. So just to indicate no change, I'm going to just do a plus 0, right, because that means no change. You don't have to put a plus 0, I'm just trying to give it to you in a mathematical format to help you remember. So that's going to be 5, 0, 0, 0, 0. So then 53,789 rounds to 50,000. Alright, so I hope I made the point very, very clear. So thank you, class. I will see you in the next video.